All right, our next speaker is going to take us in a bit of a different direction again. Our next speaker is Giovanni Santostasi, and he discovered the Bitcoin power law, which is an interesting way of looking at Bitcoin over the past and has some predictions about what it's going to do in the future. So I'll let Giovanni explain all that. So please welcome Giovanni Santostasi.
Thank you. I'm talking about the Bitcoin power law theory, and I will explain why there is law there, what power is, theory, why theory. But the title, you can see it's actually very strong connections with the previous speakers. We are discussing human value, things that we can measure, like hash rate, energy, time, and price. I know that many Bitcoiners, the hardcore ones, they say, I don't care about price, whatever. You do care. I know you say that philosophically, but everybody cares about price. But if you don't want to care about, we're going up, down, at least it's a measure. It's some kind of a measure. Because maybe differently from Nat, I want to discuss with him about Austrian economics, because I'm trying to understand it. But I am a physicist, right? That is my background. I have a PhD in physics, astrophysics. And I was a professor for many years. And you will say, what a physicist has to do with economics? Well, we have an entire branch of physics called econophysics that was answer to economics. We were not happy, and so we created our own branch of physics that is called econophysics. So physicists actually started to study social systems and even economics. And we did a lot of progress where economy people got stuck. Anyway, so let's move further. Okay, so this is one of the slides I'm using because when I started to talk about this publicly, I know it sounds grandiose, but I felt almost like I'm from Italy, like my hero, that is Galileo. And the entire idea is I'm trying to ask people to look at the telescope, inside the telescope, right? Because that is one of the things that Galileo did when he started to study the solar system. He said, look, there is this tool, let's use this tool to understand what is going on. And I'm trying to do the same. I think that Bitcoin can be studied as a science. I'm actually creating an institute. It's called the Scientific Bitcoin Institute. It's a non-profit organization. I want to bring other scientists, scholars, to make Bitcoin a scientific topic. Maybe even one day there will be a degree in studying Bitcoin scientifically. So I'm using price mostly because as a scientist, right, I don't start from axioms like I disagree with that with Austrian economics because, if you went at the time of Galileo, it was all about axioms. Basically, people waking up in the morning and say, hey, the universe works like this. And if you ask the most intelligent person in the world, you take two stones, a big stone and a small stone, and you drop them at the same time, everybody will say the big stones arrive first. And Galileo say, well, let's do the experiment. Do it. You drop a big stone and a small stone, they arrive at the same time. For millennia, people say, no, from first principle. They thought we started from first principle. No, the big stones arrive first. It was bullshit. I'm sorry, for the word. I like direct language, right? It was not true. So we like to see the data, in physics. We start from the data, from observations, and then we are trying to understand the mechanism behind. So you look at Bitcoin price, and this is what is shown all the time in these. I live in the US since 30 years. There are all these financial shows, and always they show this chart. It's a chart where I'm plotting the price linearly, so just directly the price. I don't do any transformation, any modification of the price. And then I have time. We measure time in these charts using days, or you can use months, weeks, whatever. Days since the beginning of Bitcoin, right? January 3, 2009. So that is my x-axis, time measuring days, months, whatever. You can use minutes. I like days because it's a good balance between, long enough time and you have enough information there, enough days. Right now, I think you can check it on your Google. I think that is actually will be useful because at a certain point, I'm going to ask you to calculate the price that my theory says it should be right now for Bitcoin. So if you want to participate to this exercise, you can start to check. You can ask Google, how many days today from January 3, 2009? And somebody maybe can tell you. I think it's on the order of 6,100, something like that. Okay, please check for me if you want to. Okay, so the next slide is this one. So one of the things that, oh, and by the way, if I go back, right, the main point about this chart is you don't see any particular pattern, right? Yeah, it seems that the price is going up, but there are times when we reach some peak, we collapsed, and it doesn't give a lot of confidence to people, right? In particular, people that don't understand everything about Bitcoin. I know that many of you came to Bitcoin not because of a chart, but the fundamentals. But this is the evidence. For a physicist, I want to see what Bitcoin does, right? Not just, I understood the technology from the beginning. I got into Bitcoin since 2000. I downloaded the wallet in 2010. I didn't do much with it. And then in 2012, I got orange-pilled by an engineer that was speaking the right language, but also he had a chart of Bitcoin. He didn't talk about the power law, but I saw some organization and some order in that chart. And this is what orange-pilled me, okay? Everybody comes from different angles. For a physicist, evidence and data is fundamental. And so you look at this, and it doesn't give you any confidence, right? Bitcoin can go to zero at any moment. This is what you will think, right? There are such big drops that why doesn't go to zero, right? So one of the things we do, this is also when people took my classes in physics, right? If there is a phenomena that covers many, many order of magnitudes, what do I mean for order of magnitude? Is big changes. It's almost like you're taking a drone, you're flying above a forest, and you want to see the forest as a whole. So in that case, you are not interested in small changes. You want to see changes of tens, right? These are called, by the way, there is a term for that in physics. We call it order of magnitude or scale, okay? Scale is a critical term in this presentation. So you're looking at changes of scale, so 10, 100, 1,000, and we know that Bitcoin went through these changes. For example, the first transaction in Bitcoin was one Bitcoin for $1 for 10,000 Bitcoin, close to that. And now it's close to 100,000, right? So that is 8 order of magnitude or 100 million pair. Can you imagine? Bitcoin went through a transformation of 100 million pair, okay? So when you have something like that changes over many, many order of magnitude, an analogy, imagine you have a grain of sand in your hand, and this grain of sand in 16 years becomes literally Mount Everest. That is the range of change that Bitcoin went through. It's incredible, okay? So we take what is called the log, okay? Hopefully, most of you knows what is a log, but just to give you an idea, it's a function where if you represent the number as powers, right? So you have 10, is 10 to the 1, right? Because you're taking 10. Then if I have 100, is 10 times 10, right? So I can write it as 10 to the second. If I have 1,000, I have 10 times 10 times 10, 10 to the 3, right? So that exponent is the power. This is why we are talking about a power law. So if you take a log, it depends on the basis, but without going in technicality, log base 10 of 100 gives me that exponent, 2. So it's like a box, you put in something, it spits out something, right? You put 100, it gives you 2. You put 1,000, it gives you 3. 10,000 gives you 4. What is the relevance of that? So for example, everybody has heard of Richter scale, right, in earthquakes. That is this type of transformation, because if you have an earthquake of scale 4, the one of scale 5 seems just slightly bigger than 4, is actually 10 times stronger, because it's the scale. Really, we are describing the scale. So an earthquake scale 6 is 100 times stronger than that earthquake scale 4, okay? So we are talking about that. So when you do this transformation, so I'm taking the log of the price, all of a sudden, so forget about the colors, the stars, by the way, indicate halving events. All of a sudden, that messy chart becomes much more organized and orderly, right? It looks like there is some kind of a pattern. There is this curve that is kind of bending, right? There is not an asymptote. Asymptote means there is some kind of a ceiling. There is not such a thing. I saw even macroeconomic experts of Fidelity saying, oh, there is an asymptote. There is not an asymptote. This curve continues forever, okay? It goes up forever. But it seems to slow down, right? A little bit, because it's curved like that. Okay, so but looking at this curve, you will not know if there is a particular pattern there, right? Okay, seems orderly, seems nicer. Even the big, huge deviations, right, the bubbles, seems much more tame. But it will be difficult to say what it is. Now, we know what it is not. What is not, it's an exponential. Because in this chart, if I have an exponential, what is an exponential? It's a pattern that we see often in nature, and is something that grows at constant rate. So if you have, for example, cells that reproduce, right? So you start with one cell, it doubles, the two cells double again, double again, double again. This process is an exponential process. And in a linear chart like the one in the beginning, I showed, linear x and linear y, it will look like some kind of J, like a hockey stick. In this chart, that exponential process will look like a straight line. And you can see Bitcoin is not a straight line, because this was something that even now they say, oh, Bitcoin works like an exponential or grows exponentially. It's not true, because you can see Bitcoin is curving, and an exponential will go straight. So it is not. So is there some other type of equation, process we can describe? So we have an ultimate tool in physics, like when my students, we study something, we gather data, linear, often many phenomena in nature looks like a line, in particular if you have small changes, because everything looks like a line if it changes little. Many times we have exponentials, and so if we do the log on the y-axis and linear in the x, you get a straight line. Of course, right, data has always some noise, but it's never perfect, right? We will have some variation. But the ultimate tool that we have in physics, and this is why this had to be discovered by a physicist, because nobody else does it, as far as I know. Economists, they even get confused. I had people say, how can you take the log of time? That is ridiculous. You can take the log of time. So in this case, I'm taking the log of time and the log of the price. And what do you notice? What do you see? Do you see something different from before? Now we have a straight line, right? There is a straight line. And when I saw this for the first time, I started to find power laws in Bitcoin since 2012. I even posted online. I should have wrote a paper, but actually I wanted to reach the community, so I posted on the famous scientific journal called Reddit, But it was a way to reach, and people attack me, say all kinds of things about, how crazy this was, that I was finding these regular patterns, because how could it be, that human action is regular, it has precise mathematical formula? Well, it is. And then I discovered this one that is price versus time around 2018. And I posted, and the title of that red post was 10 years of power law behavior, or Bitcoin power law behavior. Again, many skeptics. And then 5 years later, I show how this curve looked like, and it was exactly what I predicted 5 years before. Within certain error, but the general trend was there. And everybody went crazy, and this is how I started to be more famous in the community. I'm showing in blue, and this is not even the latest version, but blue line shows basically the time since I discovered the law. So you can see when I say I predict it, basically I'm predicting this. There are fluctuations, but these fluctuations go around that line. You will agree with me. It's a pretty good prediction, because that actually is the best prediction, because if a price is at the bottom, at the top, which one is the fair price? Well, something in the middle, right? And this curve tells you what is in the middle. Now, there are many tests, right? And there are skeptics, etc. So if you have questions, I will try to leave a few minutes for questions, so you can talk to me after the talk, right? DM me, all kind of things. But so one of the things that people think that, this is just a line, we will see it's not just a line, but it's much deeper than that. But even at this level, this line tells us there is organization, there is order, there is structure. In particular, what is the structure? There is some kind of linear relationship between the scale of time and the scale of price. This is very important because in physics, we see a lot of phenomena, I will show you some of them, where this pattern, where a scale, not the quantity itself, not the parameter itself, but the scale of a parameter is related linearly with the scale of another parameter. And we call them power laws. So if I don't go into the mathematical details, but if you know some algebra, you can convince yourself that you have something that looks like a straight line in this type of graph. It's a power law that means what? Probably it's too small, and I will have a slide where it's a little bit bigger. So we can literally write an equation that says the price is equal to some constant times the time to the power of something. And the power is given by that slope, the slope of that line. In this case, for Bitcoin, it's 5.72. And this was calculated several years ago. If you calculate it right now, it's basically the same parameter. It has not changed. And so there is also this quantity called R square, that is a statistical quantity that tells us how precise that line is, how much of a behavior of the price of Bitcoin is described by that line. And it's 0.95. So on a certain point, I moved from astrophysics to neuroscience. And we published paper in neuroscience where that R square was like 0.7, 0.6, right? That means our pattern was 60%, describes 60% of the behavior of the data we saw. In this case, is 95%. And actually, since then, we are now at 0.97. So only 3% of the behavior of a price is now described. But you could say, how come? I see this big, huge deviation, the price goes away from it. Well, because it goes as much away up than down. Basically, these bubbles cancel each other. And in the end, you're left with the power law behavior. So if you take an average, like a moving average over 4 years, all what you will see is that line. It's almost scary when you see that. Here, we try to characterize the deviation by drawing parallel lines at certain percentage deviation. You can try to make a model where you say, okay, the bubble cancel, but they are all there. So can I model them with some kind of waves or something, right? Right now, it works for, I'm not modeling the first bubble because it seems like some kind of exception. I model the other one. They happen every 4 years, but somehow we are not seeing a bubble this time, So maybe this periodicity is gone. But that is kind of on top of the power law. The power law is really the most fundamental pattern. Now, how does it look like? So here, the black line, so we go back to the linear chart where I have linear time and linear price, and I average the price, which is the black curve, over 4 years. So basically, every dot represents the average over the last 4 years, right? And this is what you're seeing, this J, but the J is not an exponential, it's a power law. In fact, the red curve is the power law. Is it a good model or not of what is going on? It's pretty good, right? They are fitted, and you can see what happened with the price. Even if I zoom here at the first days, you will see that black line oscillating around the red curve. It fits like a glove. This is almost looks like physics. It doesn't look like economics. In physics, we get this tight model, very precise. In economics, you never have this. One of my collaborators, Fred Krueger, I don't know if you know him, he just published a book where he discussed the power law. He says he was in a room with Peter Thiel and many other famous people. He showed that average. You can also do this in the log-log graph, and it will look like a straight line with this oscillating curve, right? And he said the entire room fell silent when you show that curve. Are people that understand these kind of things. Anyway, so this is the equation. If you want, we can do this exercise if you like. So how many days, did you find out how many days from the birth of Bitcoin is today? Okay, do you want to help me with the calculation? Do you have a calculator? So we can calculate by taking the day. So this is like if you average, you get, I say 5.73, but you get something close also with this value. If you average the data, you kind of smooth a little bit of the bubbles. So let's try to do this. This is the formula. The price is equal 10 to the minus 17. Why is 10 to the minus 17? Because if I go to day 1 to the power of anything means 1. The price of Bitcoin, according to this model, day 1 was 10 minus $17, right? So 0, 16 zeros, $1. Right? That is ridiculous because it simply say it was nothing. You know, it was something, but almost nothing, right? And then the value started to grow. You can ask through this equation when there was the parity with the dollar, when Bitcoin reached $1, and you can get a time, right? You can start with a price, and it will give you a time. That time is 735 days, something like that. Well, you go and look at when the dollar one Bitcoin became $1, the formula is off by 15 days or something like that, 10 days. Okay, so let's do the exercise. Can you do that calculation? 10 to the minus 17, put the number of days, take the power. We get what? $120,000. Yeah, okay, close to $120,000. This is what the formula says, that today the price is. So we are not there exactly, but we are oscillating around the price. So you see how good the equation is. It's not just by chance. I told you, I did it 5 years ago. You can do it 10 years ago. This formula works from, I even put here the first early transaction ever, and it falls exactly on the power law, the first transaction. That is crazy. Okay, and this is how I show that actually you get a power law. Okay, I want to talk about this slide. So it's not about price prediction. It's all these things. But the main message is that I have this slogan: Bitcoin is a force of nature. Somehow we created this thing, whatever you call it. It's a network. Really, many people will use this word, network. But in physics, a network is a very precise thing. And there are big books like this that show all the physics, the equations, they regulate networks, okay? And power laws are one of the things that come out from networks. Networks and power law go one to one. They love each other. And these are many examples. Now, the one on the right, I don't know if it is a network. It's possible that the most profound laws of nature are maybe networks. There are some indication of that. But in that case, it's physical nature. In fact, science started by discovering a power law. And then people started to wonder where this power law comes from. Why do we have this power law? And then Newton came about 100 years later and say, it's because of gravity, right? And there is this formula. And what I'm showing there, so this planet's one, right? I'm showing the distance of a planet from the sun versus how long it takes for the planet to go around the sun. And that is a power law. It's an equation that says the distance is equal the time, the period, right, to the 2/3. Okay, then we have this one that is a very beautiful one on the left that has to do with animals, with biology. So you have it in physics. If you go on Wikipedia and you look for power laws, there are literally maybe 400 cases where they say this law, this other law, the light that we get from the bulb, it's a power law. The intensity of the light is proportional to the temperature of the bulb to the fourth power. Every time you have a power to a relation to quantity related to a power, you have a power law. And this one is one of the most beautiful in biology because it's the mass of an animal, the one that is called the Kleber's law. It was discovered in the 30s. It's the mass of an animal versus how much energy the animal is using. So you will think, maybe if you don't think about this, scientists think about this stuff all the time, you will think there is no relationship, right? I double the size of an animal, who knows how much energy it's using because it's carnivore, it has different lifestyle from a cow, Maybe there is no a pattern. There is a pattern, is a power law. And the question is, the metabolism, the energy, is equal to the mass to the 3/4. And that is beautiful because the next guess will be, well, okay, there is a pattern, it's linear, right? I double the size of an animal, I get 2 times more energy. I triple the size of an animal, I get 3 times the energy. Instead, what happens, you double the mass of an animal, you get 1.7. So there is a discount of 70%, or 30%. So nature found a way of organizing, and guess what? The human body is a network. The cells of, what is a network? A network is when you have units, right, that are isolated and they do their own thing, but also communicate with each other, right? Like in a gas, for example, that is another type of system in science. They don't really interact much, right, just when they collide. Networks are much more complicated and interesting because we have information or material transferred from one. They are called nodes, one node and the other, and the connections are called links. This is the terminology. And they are very beautiful because they show all kinds of this very interesting self-organization. And in a body, for example, what you get is that as the organism is growing, it's fine efficiency. It's fine. You have to pay a price to be double big, but it's not that tough of a price. There is a discount, 30%. By the time you go from the mouse to the elephant is about 100,000 times bigger than a mouse, but it only consumes 10,000 more energy. So there is a discount of 10 because it's a non-linear relationship, so bigger the difference, bigger the discount. So this is beautiful. It shows that somehow the body and nature find a way of using resources in an efficient way. Think about that, how it applies to Bitcoin. It says exactly the same thing with Bitcoin, right? And then, when I presented this, people say all the time, okay, it works with it works with planets, it works with animals, but it doesn't work with humans, right? We are free agents, we can do whatever we want. It does. This is one of the things the physicists found out. We studied cities, and we found almost everything you want to study on a city, like GDP, the number of patents, the number of gas stations in a city, power laws. Even how fast somebody walks in a city is a power law between this quantity and the population size. And it works it's very universal. We use this, is actually a term that we use in physics, universal, when many different things that seem very different behave in the same way. And cities, for example, you go to US, France, I could take the Bulgarian cities. It works in history. Some people did it with ancient Roman cities. They grow up through these patterns. And also language. Language is a human activity. There is a power law that determines how likely that there is a word in a book, how many words you will find, V, 4, or whatever, how many times this word is repeated in a language. And notice there are dozens and dozens of languages. All these curves are different languages. Bulgarian is there, English is there. They are all on top of each other. It's almost like we speak the same language with small variation because the fundamental pattern of how the language is organized is the same. Even ancient Egyptian, Sanskrit, Latin. It's really, really fascinating. And so these are a list of physics law. The exponents, right? 1, 3, 5, 4. Some of the exponents are negative. It means there is an inverse relationship. These are many different type of, we call them power laws or scaling laws, because basically the main message is that somehow the system wants to organize itself where the change in one scale is proportional to the change of the other. Now, what is one of the consequences of this? Is that as the system becomes bigger and bigger, it slows down. And I say all the time, and that is because, this is why you get that curve, it looks like this, and people talk about diminishing returns, right? Bitcoin was making like 10 times the first year, right? You bought Bitcoin in 1 year, you went up in whatever investment you made, 10 pair, right? Right now, we are close to 45. In fact, the power law tells you what is your return annual, your annual return. It's almost perfectly the one that we observe. The power law can predict that. And these returns are going down. It will take, the decay is slowing down. It will take 20 years before we go to 15% or something like that. So for the next 20 years, we beat the stock market, we beat gold, because gold went up 3 times in the last 15 years, right? So it's the best investment ever, and it will continue to be for the next 20 years or more. But there are diminishing returns. So I say all the time, it's not a bug, because many people, this thing is not so popular for one main reason. People don't like that we are saying things are slowing down. People want the price to explode, okay, and become exponential. Exponentials are bad. There is this beautiful talk, I suggest everybody to watch it. It's called The Surprising Math of Cities and Corporations by this physicist called Geoffrey West. And he's like an expert in power laws. He wrote a book, again, if you want to, I think it's the best book to understand Bitcoin after the Bitcoin standard, literally. Until I write my book that is called The Physics of Bitcoin, and then you can read that one. But this one is called Scale. And I'm sure there is an Hungarian version, there is an English version, Italian version. And it's all about, it's a big book like this, about the relevance of scale to understand the universe. One of the commentary, one of the reviews says, if you don't understand scale, you don't understand the universe. So scale is one of the most important concepts. And so what is the feature instead of being a bug? Is it gives the system to adapt, because power laws are adaptable, they are sustainable, you can do things to them, they tend to this equilibrium, while exponential, they are not. They grow very fast and they collapse. In fact, in that lecture that I told you, The Surprising Math of City Corporation, Geoffrey West shows these power laws that apply to cities, and then he studied thousands and thousands of corporations, and all of them grow as exponential. And it shows that all of them don't last more than 100 years. They die. In fact, he has a joke and say, the only corporation that live more than 100 years is the Vatican, right, in Rome. It's a joke, but hopefully you get it. But then he says, while cities take Rome, all these, Sofia, they had a version of Sofia, right, in Roman times, right? It's thousands of years old. Rome is thousands of years old. You can nuke a city like Hiroshima and Nagasaki. They come back. Cities are eternal because they follow power law. Which one do you like? Bitcoin to die or to be eternal? I liked eternal, so I vote for power laws. Power law. When I hear people say, "Oh, maybe it's going to be broken," the power law, they really want that power law not to be diminishing returns. It's actually bad for Bitcoin. We want something that is stable, that gives chance for legislation, for regulation, for different system to come in. Bigger and bigger system is part of this scaling process. So this is, you can check, you can do your own research. This is showing all the different power laws that are relevant. And notice what he say, predictable city. Why is predictable? Because that is the other comment that I hear all the time from people. Well, this is describe a past, but it doesn't describe a future. It does. But if there is one single thing that physicists use to predict the future, and physics will be worthless if we cannot predict anything, it's all about prediction. Science is about prediction. It's scaling pattern, because it means there is some kind of a process, there is some kind of behavior that makes the power law show up. And I don't have much time, but if you want to discover my work, go. I wrote many articles. I have a YouTube channel. I am on X. I'm very active. I discover that has to do with two things. The addresses, that is a proxy for adoption, grow like a power law. They don't grow as an S-curve, like many people say. S-curves are typical of many technologies, how technologies are adopted. But Bitcoin doesn't follow them. It follows a power law. It's a power law where the slope, it's cube. And then the price responds to the adoption, to the growth of the addresses with the square. And this is why we have something close to SIC, because the addresses is basically Bitcoiners. So we Bitcoiners grow with the time to the cube, and then the price responds with the square. So if you double the number of Bitcoiners, we get 4 times the price. If you triple the number of Bitcoiners, we get 9 times the price. So these two laws that describe adoption and then how price reacts, they're actually network effect. One, for example, viruses, many viruses grow like power law. The internet grew like a power law with the cube, exactly like one is 2.79, and Bitcoin actually grows faster than internet, something 2.8, something like that. Close to 3. This 3 is kind of a magical number for system to grow. And then there is a name for the reaction of the price that is the square. It's called the Metcalfe law. Maybe you heard. This engineer found a pattern in network where the value of a network is the square of the nodes, of the people involved in the, of the people, computer, or whatever. Let me see if there is cities. This is by way of a lecture, the tutorial, the surprising math of city corporation. Scale the book. Please read. You see the universal laws of growth, innovation, sustainability, and the pace of life in organic cities, economy, company. So the main message, I have many other slides. It goes deeper and deeper. I have a show every Wednesday called The Physics of Bitcoin, and I do it. In fact, he's one of the people that Robin showed is my colleague. He's an astrophysicist from Harvard, and we go every week. We discover something new about Bitcoin, like a new result. So it will take me 5 days to tell you all the things I discovered. So this is a summary, right? But please go deep, on this. Whenever you have a chance, start to read some of my articles. You can interact with me online. It's a really fascinating topic. I'm starting to write some articles. These are the different power laws I discover. I discover that addresses are a power law, that price is a power law, that hash rate is a power law. They are all interacting power laws. It's like a feedback loop. And that is another thing that creates power law. When you have feedback loops, power laws. So to me, as a physicist, this is pure beauty that we created this incredible experiment, interaction between humans. I completely agree with the previous speaker saying we are Bitcoin, the network, human network, the machine network, the interaction. It's a network of networks. It's a meta network. This interaction between us, without being controlled by somebody, a central authority or whatever, organized itself. It's self-organized and created this beautiful pattern. But by the way, is the pattern chosen by nature. There is several articles where they show tooth, horns, thorns, shells. They all follow power laws. And there is a reason. Nature knows, right? Through evolution, etc., is the best pattern. And Bitcoin follow this. So that is the main message. It's not about price prediction. It's not a model. I hate when people call it a model. It's a framework to understand what Bitcoin is. And, like I say, I don't want to take time from the next speaker, but I don't know if we have 1 minute for a question or two. We have to move on. Okay, you can talk to me afterwards. Thank you so much. Sorry for taking too much time.